Welcome to The Explainer. So when you hear the terms AI and 5G tossed around together, your mind probably jumps straight to the cool consumer-facing stuff, right? You're picturing self-driving cars, smart cities, maybe those incredibly fast AI virtual assistants living in the cloud. But honestly, that is just scratching the surface. The real story here, the one that's way more profound and happening right under our noses, is occurring deep inside the network itself. Because AI isn't just some app you download anymore. It's literally being woven into the very fabric of our wireless infrastructure, from the raw radio signals all the way to the core routing systems. It is completely transforming our networks into fully autonomous systems.
Okay, let's dive into this. For decades, the entire telecom model was built on what engineers lovingly called dumb pipes. And that basically meant the network was just this static, rigid piece of infrastructure designed with one simple job: push data from point A to point B. It didn't think, it just routed. But the 5G networks we're building today, they are radically different. We're looking at a full-blown transition into a living, breathing, self-learning digital organism. It's a massive, massive shift that's quietly happening right now in telecom engineering circles. And today, we're pulling back the curtain to show you exactly how the whole shebang works.
Here's our roadmap for today. First, we'll look at the physical layer magic. Then, the RAN air traffic controller. Third, the intelligent network core. Fourth, processing at the edge. Fifth, the all-seeing surveillance system. And finally, the 6G sensing future. Let's get into it.
Section 1. The physical layer magic. This is the base of 5G.
We're starting at the very bottom of the stack. This is where the actual, literal magic of wireless communication happens. It's the point where we take your digital data, paint it onto raw radio waves, and navigate the incredibly chaotic, bouncing journey those waves have to take just to find your smartphone. And I want you to notice the massive jump here, 64 to 128. In older generations of networks, cell tower might have had, just a handful of antennas. But in the world of 5G, we are now packing up to 128 individual antennas onto a single base station. That represents just a staggering increase in hardware density and capability.
And this brilliantly illustrates a real game changer of a technology known as massive MIMO. Think about it like this. Instead of a traditional cell tower acting like a giant, dumb floodlight that just blindly blankets an entire neighborhood with a signal, the tower now functions more like hundreds of tiny, powerful laser pointers. These laser pointers create highly focused beams of energy that actually track you personally as you walk down the street. But here's the catch, right? Figuring out how to aim 128 of these laser pointers simultaneously through a super messy environment where signals are bouncing off buildings and moving cars is an insanely complex math problem. Traditional mathematical algorithms simply fall apart here. There's no way they can keep up. So the network brings in AI deep learning to master that chaos, predicting exactly where that signal needs to go next to dramatically boost your data speed and coverage.
But the AI integration doesn't stop at the tower. Think about the physical path from that tower to your phone. It is incredibly noisy out there. For decades, engineers relied on really complex statistical models to clean up that messy radio signal. But now, they're using CNNs, or convolutional neural networks. These are the exact same AI models typically used for visual image recognition, like spotting a cat in a photo, but here they're being used to reconstruct a perfectly clean signal out of extreme radio noise. In fact, in some tests, these image recognition AI models are actually outperforming the classic signal processing techniques that have been the absolute gold standard in telecom for decades. It is a complete paradigm shift right at the physical layer.
Moving on to Section 2, the RAN air traffic controller, handling resource management.
All right, let's climb a little higher up the architectural ladder to the Radio Access Network, or the RAN. This layer is entirely focused on deciding who gets to talk on the network and exactly when they get to do it. And the scale of this management problem is just mind-boggling. You have a single 5G cell tower trying to play air traffic controller for thousands of devices simultaneously. You got smartphones, IoT sensors, connected cars, factory robots, all screaming for the exact same limited bandwidth. Old school schedulers just followed a rigid, pre-programmed rulebook. But the modern approach? It uses reinforcement learning. It's honestly like an AI learning to master a super complex video game. It watches the live network, tries out different strategies, and through constant trial and error, it adapts instantly to traffic jams. Whether that's rush hour on the highway or a stadium full of people suddenly trying to post videos at the exact same time, the AI handles it.
All of this dynamic intelligence culminates in a highly ambitious concept known as self-organizing networks, or SON. The goal here is a network that quite literally runs itself.
Step 1 is auto-configuration, meaning new cell towers can just be turned on and they basically set themselves up. Step 2 is auto-optimization, where the network is constantly fine-tuning antenna power and balancing loads between towers. But Step 3 is where the magic really happens, auto-healing. The AI can actually spot dropped packets or failing calls as you move, and it adjusts things dynamically on the fly to fix the issue. And it does this so fast, it often happens before a human engineer even gets a dashboard alert.
Section 3, the Intelligent Network Core. This is essentially the brain of 5G.
Let's move to network slicing and see how this builds into the brain of the whole telecom operation. The absolute biggest shift you have to understand here is that the 5G core is no longer made up of old-school specialized telecom hardware. Nope, it is basically pure software running in the cloud. And this unlocks one of 5G's absolute superpowers, network slicing. Because the core is pure software, we can take one giant digital highway and literally slice it up into dedicated private virtual lanes. So you have a standard lane for everyday smartphones, you have an ultra-fast, low-latency lane exclusively for factory robots, and you have a super reliable lane reserved only for emergency services. And the traffic cop deciding exactly how wide each of these virtual lanes should be in real time? Yeah, you guessed it, it's AI.
Now, there is a flip side to this. When your entire core is software, you inadvertently open up new doors for bad actors. Because of the software-based vulnerability, AI models essentially act as an AI core patrol operating 24/7. They are constantly analyzing network behavior deep inside the core, proactively hunting for anything that seems even slightly off. Whether it's fraud, strange signaling behaviors, or the very beginning of a massive DDoS attack, the AI is designed to be completely proactive. It basically acts as the network's autonomous immune system.
Section 4, processing at the edge, where we focus on crushing latency.
So, we've been deep in the core, but now we're pushing all the way back out to the very edge of the network. This is where the processing power is moved physically closer to you, the user. The big idea here is beautifully simple. Instead of sending every single piece of data on a long, slow trip to a distant cloud server, we just do the processing right where the action is. By skipping that long round trip, you absolutely crush latency. We are talking about decisions getting made in milliseconds. And to put that into perspective, this is the life or death difference between a self-driving car braking instantly to avoid a hazard versus reacting a half-second too late. Edge processing is the key that makes real-time public safety video and instant robot reactions a reality.
Section 5, the all-seeing surveillance system, the network that watches back. So the crucial point is, everything we've covered up to this point has been about making the network faster, more efficient, and smarter. But what happens when those exact same optimization tools are turned around to watch us? In the intelligence world, this is known as pattern of life intelligence. You see, the exact same AI that optimizes your signal strength can be used to monitor users. Machine learning models are incredibly adept at connecting the dots of our daily routines. They can find patterns and draw highly detailed conclusions about our lives that would be completely invisible to a human simply sifting through a mountain of raw data.
Look, even if you use secure apps and every single text message you send is perfectly encrypted, the network inherently generates an unbelievable amount of metadata. We are talking about your precise location data, a log of exactly which cell towers you connect to throughout the entire day, the strength of your signal at any given moment, and your exact data usage patterns. By themselves, sure, these data points might seem totally meaningless, but when fed into an AI model, it paints a staggering, granular picture of your daily commute, who you meet with, and when you're away from home. And it does all of this without ever reading a single encrypted message. It's all just metadata.
And finally, Section 6. The 6G sensing future, moving way beyond just communication. Now, what's really interesting about this slide is that if the metadata generation of 5G seems powerful, what telecom engineers are developing right now for 6G is straight out of science fiction. It centers on a concept called Integrated Sensing and Communication, or ISAC for short. The fundamental idea behind 6G is to use the communication radio signals themselves as a kind of active radar. By analyzing exactly how those radio waves bounce off objects in the environment, the network could literally sense physical movement. It could detect the presence of a person in a room, even if they aren't carrying a phone or a connected device at all. 6G essentially erases the line between communicating and sensing, turning the entire telecom infrastructure into a massive distributed sensing system that is constantly observing the physical world.
We've seen how our infrastructure is transforming from static pipes into autonomous, self-learning systems. AI is literally baked into every single layer, granting these networks incredible power to optimize and connect. But as we've seen,
it also grants them an unprecedented power to monitor. Which brings us to a rather chilling reality. As we build these all-seeing, self-aware systems, when a network can literally see the world, who controls its vision? That is something very important for all of us to chew on. Thanks for joining me for this explainer, and keep learning.